This video I'm going to show you how to simplify algebra using the index laws. Now some of these index laws are quite straightforward, and near the end of the video you'll see that they get quite advanced. Now in this first example I'm just going to go through the four basic laws of indices or powers. So in this first case I've got t to the power of 3 times t to the power of 5. Now these index laws work when we have the same base. Now in this case the base is t, and it's clearly the same because both parts have a t in it. So what happens when I times two powers together? Well, the first index law tells me that when I times two powers together, I've got to add the indices. So I can simplify this up by saying t to the power of 3 plus 5, which is t to the power of 8. Okay, so question B here, I've got p to the power of 7 divided by p to the power of 4. Now here again I've got the same base, this time it's p, and when I divide powers I can simplify it up by minusing them. So I've got p to the power of 7 minus 4 because they're being divided, and I get p to the power of 3. Question C here, you can see that I've got a power then raised to another power after this, and the index law for this tells me that I've got to multiply my two powers together. So here I've got m to the power of 4 times 6, and that is m to the power of 24. And lastly here you can see I've got a y to the power of 0. Now, powering anything to 0 just gives an answer of 1. So you can have a really complicated function. If you raise it to the power of 0, you'll end up by just getting 1. Okay, so just to recap those four properties of indices, if you multiply two indices together, you've just add the numbers up. When you divide two indices together, you take them away. When you power another power, you multiply, and anything to the power of 0 is 1. So use this piece of information to have a go at these practice questions over here on the right. Pause the video and I'll run through the answers in a moment. Okay, so the first one was a times, and if you remember from the indice laws, that means I've got to add the powers. So I've got g to the power of 5 plus 7, which is g to the power of 12. Second one, I've got to take away. So I've got b to the power of 8 minus 8, which is b to the power of 0. And hopefully you notice that anything to the power of 0 is just going to be the number 1. And finally, down the bottom here, I've got k to the power of 3 to the power of 5. So that's k to the power of 3 times 5, which is k to the power of 15. Okay, so in this next example, we're going to incorporate numbers into these bits of algebra. Now, we know how to deal with numbers because they just times, divide, power up as normal. And we now know how to deal with powers. So what we're going to do is just treat each bit separately, numbers and letters, and we'll get the answer out at the end. So here we've got 5t to the power of 5 times 2t to the power of 4. So first off, going to just multiply the numbers normally, 5 times 2. Okay, now I'm also going to be doing the powers which we've just learned. So I've got t to the power of 5 times t to the power of 4. I just add the powers up. So here I've got 5 times 2 is 10, and I've got t to the power of 5 plus 4, which is 9. So simplified, I get 10t to the power of 9. In this next question, I've got 8p to the power of 3 divided by 4p squared. So again, I'm just going to divide my numbers normally, 8 divided by 4, and I'm also going to take away the powers because they're being divided. So here I've got 8 divided by 4, which is 2, p to the power of 3 minus 2, which is 1, so I can just write that as 2p. Finally, I have got 2m to the power of 8, all to the power of 3. Now, this is one that people make a lot of mistakes on, because firstly, we've got to power that 2 up. All right, so it's 2 to the power of 3. And then we're going to do m to the power of 8 to the power of 3. Remember, we've got to times the powers, 8 times 3. So remember here, 2 to the power of 3, I've got to times it by itself a number of times here. In this case, I'm timesing it 2 times. So it's 2 times 2 times 2, 3 of those 2's. And I've still got this m to the power of 8 times 3. So 2 times 2 is 4, times by 2 again is 8. M to the power of 8 times 3 is 24. So I've got 8m to the power of 24. Okay, so again, pause the video, have a go at these over the other side. Just remember to times the numbers, divide the numbers, or power the numbers normally, and then use your index rules to deal with the pieces of algebra. Okay, so in this first question here, I have got 7 times 3. And I've also got g to the power of 4 times g to the power of 3. So I've got to add those two powers together. So 7 times 3 is 21. G, 4 plus 3 is 7. So I get 21g to the power of 7. This next question is, I'm going to start by dividing the numbers. 15 divided by 5. And then I've got b to the power of 9 divided by b to the power of 3. So I've got to take away 3 from 9. So 15 divided by 5 is 3. B to the power of 9 minus 3 is 6. So 3b to the power of 6. Okay, so this next one, I've got 2 to the power of 4. Then I've got k to the power of 7 to the power of 4. So I've got to times those two. So 2 to the power of 4 is 2 times 2 times 2 times 2. And then I've got k to the power of 7 times 4. So 2 times 2 is 4, times by 2 again is 8, times by another 2 is 16. K to the power of 7 times 4 is 28. So here I've got 16k to the power of 28. Okay, so the next example I am going to go through is going to be a combination of index laws acting on each other. So in this first case, I've got t to the power of 6 times t to the power of 5 all over t to the power of 7. So hopefully you've noticed that I've got a times and a divide going on. Now the way to deal with these is to deal with the numerator and denominator separately before doing the divide. So here I've got a sum on the numerator at the top, so I'm just going to deal with that first. So that is t to the power of 6 times t to the power of 5. So I've got to add those powers up. And then I'm going to be dividing it by t to the power of 7. So t to the power of 6 plus 5 is t to the power of 11 over t to the power of 7. Now I know that when I'm dividing powers, I've got to take them away. So 11 take away 7 is t to the power of 4. Now this works exactly the same way when you've got numbers involved as well. I'm going to deal with the numerator and denominator first, and then I'm going to divide afterwards. So firstly, I've got 8 times 3, and I've got c to the power of 4 times c to the power of 7, so that's 4 plus 7, all over 6c to the power of 9. So 8 times 3 is 24, c to the power of 4 plus 7 is 11, all divided by 6c to the power of 9. So now I'm going to do my divide, so I've got 24 divided by 6, and I've got c to the 11 minus 9, because I'm dividing the powers 11 and 9. So that gives me an answer of 24 divided by 6 is 4, c to the power of 2, or c squared, so 4c squared. So again, I've got 2 for you to have a go at on the right here. Pause the video and have a go. Okay then, so for this first one, I've got s to the power of 6 plus 5 all over s to the 4. That's going to be s to the 11 over s to the 4. And now I'm dividing, so I need to do s to the 11 minus 4, which is s to the power of 7. This one down the bottom here, I've got numbers involved, so I'm just going to times the numbers to begin with. 6 times 2, and I've got g to the power of 6 plus 4, because they're being timesed, divided by 3, g to the power of 3. So here 6 times 2 is 12, g to the power of 10, over 3g to the power of 3. So now I'm dividing them, so I've got 12 divided by 3, numbers divide normally, g to the power of 10 minus 3 because the powers are being divided, and I get 4g to the power of 7. Okay, so in these last examples, I'm going to go through the higher level index laws. So what happens when we have a negative power and what happens when we have a fraction power. Now, before I do this, I'm going to go through what this word reciprocal means. A couple of times I've seen on G.C.S.E paper, they ask you to write the reciprocal of a number. Now, the reciprocal just means 1 over that number. So in this case here, I want the reciprocal of 3. That's just going to be 1 over 3. Now, in the second example, I want to do the reciprocal of 1/4. Well, this is just 1 over 1/4, or 1 divided by 1/4. Now, if you remember, dividing means how many of that bottom number goes into the top number. So how many quarters fit into a whole? Well, that is 4. So the reciprocal of 1/4 is 4. Now, things get a little bit more confusing when we have something like 2/5. Again, the reciprocal is 1 over 2/5. And in fact, this ends up by simplifying down to being 5 over 2. So when you do have a fraction, you'll find that the reciprocal is just that fraction flipped over on itself. So the numerator becomes the denominator and the denominator becomes the numerator. Okay, so now we know what this word reciprocal means. We're going to look at what happens with negative powers. Now, when a power becomes negative, it means the reciprocal of that value. So here, I'm asked to work out the value of 5 to the power of minus 2. So this is asking me to write the reciprocal of 5 squared. So that minus just means the reciprocal of. So I know that the reciprocal means 1 over 5 squared. And I know that 5 squared is 25, so this is just going to be 1 over 25. So next we're going to look at what happens when we power up by a fraction. Now here I've got 25 to the power of a half. Now a power of a half actually means square root. So here I'm asked to square root 25. Now the square root of 25 is 5 because 5 times 5 is 25. If you remember, square root is the opposite of squaring. Now things get even more complicated when I have a power like 3/4. Now here, not only do I need to do the 4th root of 16 due to that denominator of 4, but then after I've got my answer, I've got to power it to the power of 3, or cube it. So here I know that the 4th root of 16 is 2, because 2 times 2 times 2 times 2 is 16. And then I've got to power that 2 up to the power of 3. So I know that 2 times 2 is 4, times 2 again is 8. So my answer is 8. So again, have a go at these questions over on the right here. Pause the video and see how you do. Okay, so starting with the reciprocal questions. Firstly, I want the reciprocal of 8. That is just 1 over 8. The reciprocal of 1/5 is 1 over 1/5, which just ends up being 5. And the reciprocal of 3 over 10 is just 10 over 3. That fraction flips over on itself. Now I want to work out 3 to the power of minus 3. Well, I know that's just going to be the reciprocal of 3 cubed. So I know that 3 cubed is 3 times 3 times 3. So 3 times 3 is 9, times 3 again is 27. So that is 1 over 27. Now I'm asked to work out 81 to the power of 1/4. So here 1/4 means not only the root of 81, but it's the 4th root of 81. So I'm looking for a number that not only times by itself, but times by itself and times by itself again gives me the answer of 81. And in this case, there's only one number that does that, and that is 3. And lastly, I'm asked to work out 8 to the power of 2/3. So here the denominator is 3, so I've got to do the 3rd root of 8. And after I've done that, I'm going to power it up to the power of 2. So the 3rd root of 8 is 2. So I've got to do 2 squared, which equals 4. So my answer there is 4. Okay, so I hope that's helped you to answer questions now on the index laws. Don't worry too much if these last examples were a little bit hard. They are A&A star topics, okay? Just make sure that you're practicing all those other examples that we went through about timesing powers, dividing powers, and powering powers up. And especially looking at questions where you've also got numbers involved as well. Okay, have a go at some practice questions and good luck.